Section 4.2 is on adding and subtracting radicals. So when you add or subtract radicals, it's much like adding and subtracting in algebra. So for example, if you remember algebra a statement something like 2x plus 3x, you can only add those together if they both have the same variable part, which is both of these have the variable x. So they would be combined as 5x. So this is very similar to how you would add radicals such as 2 root 5 and 3 root 5. They both have the exact same radical part, the square root of 5. So that means you could put those together as 5 root 5. So when we look at kind of developing a rule for adding or subtracting radicals, basically we have to have the same radical symbol and the same radicand. So radicals with the same index, if you want, because the radical symbol has to have the same, like they both have to be cube roots, or they both have to be square roots or whatever, and the same value under the radical sign, which is the same radicand. And they would be considered like radicals, and therefore you could add or subtract them. So if we look at the examples below here and identify which ones are like radicals, the first one has negative root 3 and 7 root 3. They both have the exact same radical part, root 3. So therefore they would be considered like radicals. 5 root 2 and 8 root 8, as they're written, are not like radicals, but if you investigate root 8 a little bit further, root 8 can be broken down as 4 times 2. Perfect square factor of 4 can come out as square root of 4 is 2, and you'd just be left with the root 2 inside. So therefore 5 root 2 and 2 root 2 both have the same radical part, root 2, and they would be considered like. 2 root 3 and root 2, though, are broken down as much as they can be. They're simplified as much as they can be, and root 3 is not the same as root 2. They're not like, because the radicands are different. When they're simplified. And both of them are already simplified radicals. This one here, they both have a 12 underneath the root sign, but this one has an index of 3, and this one only has an index of 2, understood to be 2. So therefore these are not like, because the index is not the same. For both. Index has to be the same for both. Alright, so we're going to use our rules now to write each expression below in simplest radical form. So for the first one, we've got 4 root 10 and root 10, which is understood to be a 1 root 10. So that means you've got 4 plus 1, or 5 root 10s. The next one, again, these are both radicals that are like root 3s. So 5 root 3, take away 2 root 3 is like saying 5, take away 2, or 3 root 3s. It'd be like adding 5x minus 2x, right? You'd get 3x. Alright, these ones here again, the radical part is root 2, and root 2 for all of them. So again, you just basically subtract, or add or subtract the numbers in front of those radicals. So 9 take away 4 is 5, take away another 4 is 1 root 2, which can be simply written as root 2. D, you've got, if you look at the whole statement there, expression, you've got 2 root 6 terms, which means 8 root 6s plus 2 root 6s is 10 root 6s, because since 8 plus 2 is 10. And then you've got root 5s, 2 terms with root 5 in them. So negative 4 root 5 minus another 4 root 5 is negative 8 root 5. Again, it's like adding the negative 4 and the negative 4. Root 3 plus root 48 right now as they're written do not look like they're like radicals, but root 48 can be broken down. So we're going to break down root 48 into its perfect square factor of 16. The product of 16 and 3 gives you 48, and then that would equal root 3. The square root of 16 can come out as a 4, and you're just left with square root of 3. And that gives you root 3 plus 4 root 3. It's like saying 1 root 3 plus 4 root 3, or 5 root 3's. Okay, so the next few, if you have root 40 plus root 90, again, they're not radicals that are like as they are written there, but both of those radicals can be broken down further. And root 40 is the same as 4 times 10. 4 is a perfect square factor, so that's why we break it down into that product. And 90 has 9 as a perfect square factor of 90. And then each of those can be written as square root of 4 can come out as a 2, root 10, plus the square root of 9 can come out as a 3, root 10, and then that would give you 2 root 10's plus 3 root 10's, or 5 root 10's. Again, it's like saying 2x plus 3x, same kind of idea. So the next one, again, the radicals as they are written do not have, they're not like radicals. So we're just going to break each of those down to see if they can be added or subtracted, if they are like radicals when simplified. So 75 has a perfect square factor of 25. So that would be 25 times 3 is 75. And then the next one, oops, is a minus. That would be 48 has a perfect square factor of 16. 16 times 3 is 48. And 27 has a perfect square factor of 9. 9 times 3 is 27. So that would give you 6 square root of 25 comes out as 5, and you're left with just the 3 under the root sign. And the square root of 16 comes out as a 4. And so you're left with just the 3 under the root sign. And then the last one, the square root of 9 comes out as a 3, and you're left with just that 3 under the root sign. So we have 30, 6 times 5 is 30, root 3, minus 12 root 3, plus 6 root 3. So they're all like radicals now, with a root 3 common radical part. So 30 take away 12 is going to be 18. 18 plus 6 is 24, root 3. And that will be your simplified answer, because there is nothing, the radical 3 can't be broken down any further. Alright, the next one, again, you don't have any like radicals in the way that they're written, but all of those radicals can each be simplified further. Root 20 has perfect square factor, 20 has perfect square factor of 4, so 4 times 5 is 20. And 18 can be written as 9 times 2, because 9 is a perfect square factor of 18. 16 is a perfect square factor of 80, so 16 times 5 is 80. And 49 is a perfect square factor of 98. 49 times 2 is 98. So that becomes a half, and the square root of 4 comes out as 2. Plus, square root of 9 comes out as 3, leaving you with just a 2 under the root sign. Square root of 16 comes out as a 4, leaving you with 5 under the root sign. And square root of 49 is 7, leaving you with just the 2 under the root sign. So just simplify a little bit further. Half of 2 is 1 root 5, plus 3 root 2, minus 4 root 5, plus 7 root 2. And then if we look at these two are like radicals, because they both have root 5's, and these two are radicals, like radicals, because they both have root 2's in them. So 1 root 5 minus 4 root 5 is negative 3 root 5. And then we have 3 root 2 plus 7 root 2 would be plus 10 root 2. So 1 root 5 minus 4 root 5 is negative 3 root 5, and 3 root 2 plus 7 root 2 is 10 root 2. And that's as much as you can do with that, because these are broken down as far as they can be. They are simplified radicals, and root 5 and root 2 are not like radicals. Right, so the last one here, again, each of these radicals in the given expression can be simplified further, because they all have perfect square factors. 28 has a perfect square factor of 4. And then 128 has a perfect square factor of 64 times 2. And then 175 has a perfect square factor of 25 times 7. And then the last one, 63, has a perfect square factor of 9. 9 times 7 is 63. So this becomes 3, and the square root of 4 comes out as 2. And then a half, and the square root of 64 comes out as 8, so a half times 8. And root 2 is all that's left under the radical sign. Or 2 is left under the radical sign. And then 2 square root of 25 comes out as a 5, and you're left with 7 under the square root sign. And then a third times 3, and 7 is all that's left under the square root sign. So now this just simplify a little bit further before we put the like radicals together. 6 root 7, half of 8 is 4, root 2 minus 10 root 7 plus 1/3 times 3 is 3 over 3, which is 1 root 7. And just in case you're not familiar with that, 3 times, over third times 3. 3 is understood to be 3 over 1, so if you multiply those, you get 3 over 3, which is 1. That's how I got that 1 there. Alright, so now I look at these two radicals, or 3 radicals. All 3 radicals have root 7, so we put those radicals together. 6 take away the 10 is going to be negative 4. Negative 4 plus 1 is going to be negative 3 root 7. And you got 4 root 2 with nothing like that. So when you look at each of those radicals now, they're broken down or simplified as much as possible, because both 7 and 2 do not have any perfect square factors other than 1. So these are not like radicals and can't be added further, so you're finished. It's the simplified answer. Alright, so the next example is just basically applying some of these exact answers, radicals, keeping the exact form rather than putting them in decimal form, and just applying it to some problems. So the first question says that a triangle has side lengths of 2 root 18, 3 root 50, and 5 root 2. What's the perimeter? So the perimeter is the sum of all the exterior sides of the triangle. So if you have all 3 side lengths, the perimeter would just be the sum of all those side lengths. So 2 root 18 plus 3 root 50 plus 5 root 2. And then 18 can simplify by breaking it down as 9 times 2. Perfect square factor is 9. 50 has a perfect square factor of 25, so we'd change the square root of 50 to the square root of 25 times 2. And 5 root 2 is simplified, because 2 only has perfect square factor of 1. So then we break down this separate the 9 and 2. You get square root of 9 comes out as a 3, and you're left with square root of 2 inside, and 3 times the square root of 25 is 5, and you're still left with the 2 under the root sign, and then you've got 5 root 2 still from the previous step. So 6 root 2 plus 3 times 5 is 15 root 2 plus 5 root 2. And when you look at all those, they're all root 2's, so that means you can add those and get 6 plus 15 is 21. 21 plus 5 is 26 root 2. And the next example is similar. It's just a polygon drawn for you with the side lengths in, so if you're looking for the perimeter again, you just add up all the side lengths. So the perimeter would equal the sum of all the side lengths, so it'll be root 2 plus root 72 and another root 72, so I'm just going to write that as 2 root 72's, and then root 18, and then root 100. So root 2 you can't do anything with, but root 72 has a perfect square factor of 36. So 36 times 2 replaces the 72. 18 would be 9 times 2. And the square root of 100 100 is a perfect square and the square root of 100 is 10, so you can just replace that with the whole number 10. And then this next line would be root 2 plus 2 times root 36 is 6, and you're left with 2 under the root sign. And this 9 times 2, the square root of 9 would come out as a 3, and you'd be left with square root of 2 plus your 10. So you'd have root 2 plus 2 times 6 is 12 root 2 plus 3 root 2, whoops, 2, plus 10. And then the root 2's are all like, so you can add those as this one would be understood to be a 1 root 2 plus 12 root 2 is 13 root 2 plus another 3 root 2 is going to be 16 in total root 2's plus 10. And this would be considered the exact answer. If you were to put that in your calculator and give the decimal corresponding to 16 root 2 plus 10, that would be an approximate answer. So this is the exact answer. And the last example has a diagram, and you're asked to find the length of x and y, which you have to determine first. So if you look at where x is in the diagram, x is the hypotenuse of a right triangle. And if you remember the Pythagorean theorem, says that leg squared plus the other leg squared in a right triangle equals the hypotenuse squared. Or some of you might have done it as a squared plus b squared equals c squared, where c is always going to be the hypotenuse. So in this case we'd have, if I just come over here because I need to make some space there, we have 8 squared plus 12 squared are the two legs of the left left-sided right triangle on the left here. So 8 squared plus 12 squared equals x squared, and that's 64 plus 144 equals x squared, and that's going to be 80208. 144 is 8, and yep, 208 equals x squared. And then we have I'm just going to write x squared equals 208 this way. So if we take the square root of both sides, we have that x equals the square root of 208, which if you break that down into perfect squares, I'm just going to do it here, 208 is 2 times 104, which is going to be 2 times 52, which is going to be 4 times 13, right? Yes. So there's 2 2's and 4. So put those all together. The biggest perfect square factor is 4 times 2, which is 16. So that's going to be 16 times 13 is what's left over. And that simplifies to 4 root 13. Then you've got to do the same thing to find y with the right triangle on the right side. So we've got 6 squared plus 4 squared. The two legs of that right triangle equal the hypotenuse is y, so equal y squared. So that becomes 36 plus 16 equals y squared. So that becomes 52. 36 and 16 is 52 equals y squared. So y would equal the square root of 52. And 52, we just know from factoring over here, that 52 is 4 times 13, perfect square factor 4. And that becomes 2 root 13 if you simplify it. So therefore, if we put these two things together now, x plus y would equal 4 root 13 plus 2 root 13, which are simplified radicals which are like radicals, both have root 13, so that becomes 6 root 13 is a simplified answer for what x plus the length of x plus y, whatever the units are. We weren't given the units, so we'll just say units. And the same thing, I guess, with the other two. I should have put units up there as well. Okay, so that's the end of section 4.2, and there's some questions there on pages 188 to 189 in your textbook that you can try to practice.